Hi, everybody. I hope you guys are staying safe. You guys are staying home and isolated. I'm sure that won't be a problem for most of you. This is just a crazy world that we live in right now. I don't think I've left the house in like a week. It's been kind of crazy, but we're surviving here, right? So hopefully you guys are doing well. Hopefully you did well with the assignments from last week. Friday, you should have taken the Unit 5 test. If you have not yet done that, which most of you have, but if you haven't yet done that, make sure you go back and do that now before you move on to this module. Make sure you guys are staying on top of your assignments. I know that now that we're going to be out even longer, until at least the first part of May, you got to make sure you guys are staying on top of your assignments and making sure you're asking questions if you have them, okay? So we are going to start a brand new module today. It's module 14. Guys, we only have 2 more modules left. We've got module 14 and module 15. So this is actually a really short one. There's only 2 lessons in this module, so that means next week we're going to take a quiz over this module as well. So let's go ahead and jump into this one. Let me change to my PowerPoint view here. So our objective for today is to construct and interpret scatter plots. Okay, we're going to be looking at, this is a kind of a module that's on statistics. Okay, so making a scatter plot. So recall that a set of bivariate data, bivariate, remember the prefix bi means 2. Okay, and then variate basically means variable, right? So bivariate means 2 variable. Okay, so it's data that involves 2 variables. Bivariate data are used to explore the relationship between 2 variables. Usually those 2 variables are x and y. A lot of times we show those on a graph of some sort. Okay, you can describe bivariate data on a scatter plot. A scatter plot is a graph with points plotted to show the relationship between 2 sets of data. All right, let's look at our first explore activity here. The final question on the math test reads, how many hours did you spend studying for this test? Okay, this would be a good question to ask for you guys since we just took a test, right? So the final question on the math test, the teacher asked them how many hours they spent studying on the test. The teacher records the number of hours each student studied and the grade that the student received on the test. Okay, the results are shown right over here in this table. Okay, so you can see this student spent 0 hours and they got a score of 75%. This student studied for half an hour, got an 80, and so on. An hour, hour and a half, all the way up to 4 hours, that person got a 90. So part A says, make a prediction about the relationship between the number of hours spent studying and the test grades, right? So as you can think, like you might make a prediction, oh yeah, the more that somebody studies, the higher the grade they're going to get, right? That makes sense. Okay, if you don't study at all, you're probably not going to get as high of a test grade as somebody who studied for 2 or 3 hours, right? That's just kind of how it usually goes. So that's a good prediction that we can make. B then says, make a scatter plot. Graph hours spent studying as the independent variable. Remember, the independent variable is your x. Okay, and test grades as the dependent variable, so test grades is going to be our y. Okay, so test grades is y, hours spent studying x. And we want to just go ahead and plot this data into our graph. So our first point is going to be 0 hours gets a score of 75. So at 0, we're going to put a point here at 75 right there. Next one is 0.580. So we'll come and plot a point right there. Next one is 1 hour and 80 is the test grade. So put a point there. 185 is their next point right there. 1.5, 85 is the next one right there. 1.5, 95. So right there. 290. So right there. 3, 100. This person got a perfect score right there. And then 490 would go right there. Okay. So So here's our scatter plot. Okay. So you can see kind of it shows an upward progression. Okay, as the number of hours spent studying increases, the test grades also generally tend to increase as well. Okay, kind of the exception would be like this person that's over here studied for 4 hours and got a 90, whereas this person right here studied for 3 hours and got 100, right? So obviously it's not going to be the same for everybody, but in general, the more hours you spend studying, the higher your grade is going to be. Okay, so that's kind of the trend that we can see. Okay, as we spend more hours studying, the test grades are going up. That's the trend that we can see. So it's kind of like this upwards trajectory, an upward slope, right? Number 2 says, do you think the grade associated with studying for 10 hours would follow this trend? So if we go back to our scatter plot here, the highest on the graph is 5, right? So if we went all the way to 10, which is going to be like way off the graph, right, is it going to continue the trend? So if we continue this trend, right, this trend's going up and up and up, is it going to continue to go up if we study for 10 hours at the same rate? Probably not, right? Because if we keep studying for 10 hours, you can't, the highest grade you can get is 100%, right? So eventually, this trend is going to kind of even off once you get to 100%, right? So granted, the person who's studying for 10 hours is definitely going to get a higher grade than somebody who studies for 0 hours. But the trend isn't going to keep going up and up and up in this case, because the highest grade that you can get is 100%. All right, now, there's also some things called clusters and outliers I want to talk about. A cluster is a set of closely grouped data. Also remember, just want to remind you, anytime you take notes over these lessons, you can use those on your tests and quizzes. So I would really recommend you take notes over these video lessons and keep them in a notebook, because you will be able to use those on your tests and quizzes coming up. Okay. So a cluster is a set of closely grouped data. So if you've got a bunch of points that are kind of closely grouped together on a graph, that's a cluster. Data may cluster around a point or along a line. An outlier, some of you have probably heard of this word before. An outlier is a data point that is very different from the rest of the data in the set. So either it's going to be too high or too low. It's basically going to be a point that's all the way off by itself. It's kind of like it doesn't belong there. Okay. So explore activity 2. A scientist gathers information about the eruptions of Old Faithful, a geyser in Yellowstone National Park. Some of you may have been to Old Faithful. Basically, after every so long, it's just like nothing happens, and then after a little while, water will spray out of this geyser, like it's shown right here in the picture. Okay, so this person uses the data to create a scatter plot. The data show the length of time between the eruptions, which is the interval, and how long the eruption lasts, which is the duration. So she's keeping track of basically how long it was in between each eruption, and then for each eruption, she's marking how high the eruption is. Okay, so part A says, describe any clusters that you see in the scatter plot. So remember, the clusters are the points that are grouped together. I see 2 real main clusters here, right? There's a cluster right here, and then there's a cluster right here as well. Okay, so there's 2 clusters. Okay, this cluster is between 40 and 60 minutes. Okay, for these eruptions, it looks like the duration of the eruption, right? So how long it sprayed up is between 1.5 and 2.5 minutes for each one. This cluster looks like it's between about 65 and 85-ish, okay? And it looks like the duration for those is between 3 minutes and 5 minutes, okay? B says, what do the clusters tell you about eruptions of Old Faithful? What do you guys think? For me, these clusters kind of tell me that the eruptions are somewhat predictable. Okay, so it kind of tells you that if there's a shorter time in between eruptions, like in this cluster right here, that means that the duration of the eruption isn't going to be as long. If there is a longer interval, like a longer period of time in that there's no eruption, like if it's just quiet for like 3 to 5 minutes, or sorry, if it's quiet between 65 to 85 minutes, that means that the eruption is going to be longer, probably between 3 and 5 minutes. Okay? And then C says describe any outliers you see in the scatter plot. So here's our clusters right here again. Okay, to me, there's one point that kind of seems like it's by itself, and that's this point right here. This point happens around like 58 minutes, right? Right about 58 minutes, and it lasts over 3 minutes for the eruption. Okay. Now, typically, if we go by this trend, if there's just an interval of 57 minutes, this point should be down in this cluster if you go by the averages. But instead, it's not. It's up in here. So this kind of tells me that it's a little bit of an outlier. Okay? It's different from the norm. And then this reflection question says, suppose the geyser erupts for 2.2 minutes after a 75-minute interval. Would this point lie in one of the clusters? So 2.2 minutes is how long it lasts. So here's 2, here's 2.5. So 2.2 would be right around in here. And it's after a 75-minute interval. So 70 minutes, 75 would be right around in here. So if we go by this, so right around here is that eruption. Okay. So would this point lie in one of the clusters? Okay, a 75-minute interval, a 2.2-minute eruption. I would say, yeah, it lies in this cluster right here. Okay, 75 and 2 and oh, sorry, I messed that up. Let me. Some of you probably saw my mistake. So 75 minutes is right here. 2.2-minute eruption would be right here. So that would give the point, make the point right there. Okay, so here's one cluster. Here's another cluster. This point is by itself, right? It's not in one of the clusters. So that would be an outlier. Sorry, I messed that first one up. Okay. All right, and then number 4. Suppose the geyser erupts for an 80-minute after an 80-minute interval. So 80 minutes is right in here. Give the range of possible duration times for which the point of the scatter plot would not be considered an outlier. So an 80-minute eruption, you would think, is going to last somewhere in this time range, right in here, right? That's between 3 and 5 minutes if it follows the general trend. Okay. And then the next thing we're going to talk about is association. Okay. Association describes how sets of data are related. A positive association means that both data sets increase together. So here, this first one is a positive association. You can see that as one variable increases, the other one also increases. One thing you can think about that is slope, right? Remember, if slope is positive, that means that it's going up from left to right. Okay, if it's negative, that means it's going down from left to right. So a negative association means that as one data set increases, the other one decreases. So here we've got negative association, and the trend line is going downwards. Okay, that's negative association. And then no association means that there's no relationship between the two data sets. Basically, the points are just going to be all over the place. So you can see in this third graph, these points are just kind of all spread out around the graph. That means there's no association whatsoever. Okay. Then data that show a positive or negative association and lie basically along a line exhibit a linear association. So you can see, like, let me erase these marks real quick. Like this and this, they don't lie, the points don't lie exactly on a straight line, but they lie mostly on a straight line. So we would say that these are pretty close to being linear. They're not exactly linear, but they're pretty close to having a linear association. And then data that shows a positive or negative association but do not lie basically on a line exhibit a nonlinear association. So like, I'll show you here in a little bit an example of a nonlinear association. Basically, it's going to be some sort of a curved association. All right, so let's look at this example. It says, Susan asked 20 people if they would buy a new product she developed at each of several prices. So she's like this inventor or something, and she's trying to come up with some sort of a price that would be best for her product. Okay, so she's asking people if they'd buy her product at certain prices. The scatter plot shows how many of the 20 said yes at a given price. Describe the association between a price and the number of buyers. Okay, so you can see on this graph, at $20, there was 2 people that said that they would buy it. Okay, sorry, I've got this mixed up. That is a price of $2. 20 people said they would buy it. So price is this down here, buyers is this here. At a $4 price, let's see, that would be 19 people said they'd buy it. At let's see, $6, 17 people said they'd buy it, and so on. Okay, all the way down to $12, and then only 2 people said they'd buy it. So basically, as you would expect, as she increases the price, fewer and fewer people are saying that they're going to buy it. Okay, so we want to first describe the association. Okay, what type of an association would this be? Would this be positive association, negative association, or no association? Well, we can kind of see that as the price increases, what's happening to the number of buyers? The number of buyers is going down, so fewer and fewer people are going to want to buy it. This shows a negative association. Okay. Now we also want to determine if it's linear or nonlinear. Okay. Well, some of you might think, oh yeah, it's linear. It's not. If you look at this, okay, it's kind of curving as it's going down. This is a nonlinear association, so it's a negative nonlinear association. Okay. Now this is a good question to ask here. It says, based on the association shown in the scatter plot, what might happen if Susan increased to $14? So if she increased the price here to $14, what do you think would happen? Well, if we go by this trend, how many people do you think are going to buy her product if she increased the price? Sorry, that's not even, that would be $13 right there. So actually, $14. No, sorry, that is $14. Yeah, $14. How many people do we think is going to buy it? Probably none. Okay, I'm sure Susan's got a great product. Okay, but if she keeps increasing the price like this, there becomes a point where people aren't going to want to buy it. So at $14, probably nobody's going to want to buy it. Okay. All right. What I want to do, this is the last thing. What I want you to do is I want you to go ahead and I want you to try this one on your own. It says the plot shows the reading level and height for 16 students in a district. So the reading level compared to the student's height. Okay, and it kind of shows what's happening here, okay, with the reading level as a student gets taller. Okay, then it says describe the association, give a possible reason for it. So is there a positive association, negative association, no association? Is it linear or nonlinear? And give a possible reason for what it is. So go ahead and pause the video, and I want you to come up with an answer on your own. Okay, and then once you unpause it, I'll have an answer for you. All right, so hopefully you were able to pause it. You took some time to answer. If you haven't, please do answer it. Come up with your own solution. Okay, we can see that as the height of a student increases, their reading level also increases. This shows a positive association. You can also see that it kind of goes in a somewhat of a straight line. So obviously, it's not a perfect line. So I would say this is also a linear association. Okay. Now we do need to come up with, it does say to describe the association and give a reason for it. What might cause the reading level of a student to go up as the student's height increases? Well, if you think about it, a student's age, the older a student gets, the taller a student gets generally. Not everybody, right? There's some 8th graders that are probably shorter than some of the 5th graders that we have, right? But that's, in general, the taller a student is, the older they are. The older a student is, the higher their reading level is, right? So you can kind of make this association. The taller a student is, probably the higher the reading level they're going to have, right? Okay, so hopefully that makes sense to you. Hopefully this lesson has made sense. If you have any questions, we are done with the lesson. Your assignment then for tonight is going to be to go onto HRW and work on the 14.1 homework. Okay, if you have any questions over it, make sure you send an email and ask. With this new schedule, hopefully you saw the new schedule. We are going Monday, Wednesday, and Friday now. Since our e-learning has been extended through at least May 1st, Dr. White has adjusted the e-learning schedule a little bit. We're only going on Mondays, Wednesdays, and Fridays now. So this assignment, you have 2 days to do. Okay, it is due on Wednesday. Okay, I'd encourage you to just go ahead and do it right now, right away. Okay, but it's not officially due until Wednesday. Okay, so again, if you have any questions, make sure you ask. Send me an email. Ask me any questions you might have. I'd be happy to answer. Okay. Have a good day, and we'll talk to you on Wednesday.